So next up is density maps and scatters. So in week 2 we created density masks from our height fields, which will be ideal for some of our scatter masks, but maybe that you want to create some of your own. Let's look at generating some of these masks in isolation and how we can control the scattering a little better. The best way to generate a lot of these masks is in VOPs. Let's jump back into our instance node. Now we're using a grid here. Let's make it a bit bigger, maybe 100. And increase the rows and the columns. And drop down a mountain node just to add a little bit more interest. And adjust the height and the element size. That's a bit better. Okay, so drop down an attribute VOP. So we created some of these masks before in our week based on height fields. So we had the height option. Let me just throw one of these down. Again, we use the vector to float and use the Y option, the Y axis option. Okay, and we can control the height based on the source min and the max here. We can do this based on normal. If I copy and paste this and take the normal instead, this helps to generate stuff like snow, which would be more apparent if we used, say, a box. Let me just add some more divisions to our grid. So all the color information here is based on the points. So the more points we have, the more information we can describe. I can show you better what this is doing if I drop down a sphere instead. Set it to polygon mesh, plug this in, and change the radius. Yeah. So we get the mask just on the top of the geometry. Jump back inside. We can, of course, use anti-alias noise like we did before. The reason I use this fit range at minus 0.4 to 0.4 is just to bring these values into a more normalized range. So if I look at just what comes out of the anti-aliased noise in the geometry spreadsheet, you can see the color goes from minus 4.16 to 0.35. And this fit range here brings it into a more usable viewing space. So it now goes from 0 to 0.94. And then I dropped in this clamp just so we could see the values a bit better. Using the Y value here from the normal also gives us a slope mask if we plug this in and invert this. we then get a mask based on the slope range. If I want to control this a little better, instead of using the fit range, we can use a ramp. I'll set this to spline. And control the values on the top level here. This way we can control the fall off a little easier if we set this to Bezier. Nice. Now we also used the Voronoi noise to generate some masks, so we can do that again. Drop this down and plug in the position. Subtract distance 1 from distance 2. Throw down a fit range just so we can clamp these values a bit better. And plug this in. And change the scale. Another way that we can use the Voronoi noise is to just generate little patches. So instead of using the distance 1 and 2, I will use the near 1 option here. So copy and paste this. We get some interesting values. Let me just take the Y value of the green channel. Cool. So now we get these little islands. We can control them using the fit range here. Now these are really good for creating masks to try and simulate farmland. We get these nice hard edges at the borders, but we can also break this up by adding a noise to affect the position before it goes into the Voronoi noise. I'll change the scale of this noise again and increase the amplitude. Now this is similar to the anti-alias noise itself, but it just gives us a little bit of a different shape and a little bit more control. Now if I wanted to add rivers that run through this, we can just do the same here, copy and paste, and add this here. And multiply this on top. Let me crank up the contrast here. And change the offset. Now obviously, ideally, we would generate all the masks that we need from the height field, but these aren't always usable, and sometimes we want to create something a little bit more custom. Another way to generate these masks is through the attribute transfer node, where we can create a fall off from one object to another. So jump back up a level and disable this attribute bob for now. I'll drop down a sphere here. Again, increase the size and change it to polygon mesh. Let's create a new attribute called density using the attribute create node. Now we could do this in the attribute wrangle, but it's good to learn about new nodes, and of course not everyone is happy or comfortable coding. So in the attribute create, we'll call this new attribute density. We'll leave it as a point attribute and float, and we'll also leave the default and the value at 0. Let me just copy and paste this one, change its defaults to 1 and 1. So now we have a density attribute assigned to the sphere with a value of 1, and another density attribute assigned to the landscape with a density value of 0. Now throw down an attribute transfer. And here we can see it's looking for the geometry to transfer the attributes to and the geometry to transfer the attributes from. So the landscape goes in the left and the sphere in the right. We can switch this to points as we know that the density attribute has been assigned to points. We can disable primitives here and choose density from the drop-down. And in the conditions tab, this is where we begin to, manage the fall off between the two attributes. But at the moment, we can't see it in the viewport, so we need to add a visualizer first before we can see what this looks like. So on the cog at the top here, we will add a visualizer, a color visualizer. Change this to points and choose density. So now we can see what this looks like in the viewport. If we go back to the conditions within the attribute transfer, we can change the fall off and the size. And of course, if we decide to change the position of this sphere at any point, the mask will follow. Nice. So let's look at the scatter node next. I'll just drop one down. Out of the box, it evenly distributes the points on the surface. If we enable density attribute, you can see that this will read from our density mask that we created. Now we could have named this anything, but density was already here, so we may as well follow along. The main options here are total count, max points, and the relax iterations. Now the first two are self-explanatory, but with the relax iterations we want to try and reduce this. This makes something a little bit more organic. We can also see that this scatter node randomizes the point order for us, so we can get rid of this. Cool. So instead of using a sphere created inside this object, I'll just go to the top level, create a new geo node, and copy and paste this in. Call this sphere. And I'll use an object merge to bring this back in. Set this into this object and choose the sphere. And plug this in. Cool. So if you had another object that you wanted to base this around, this is what you would do. Now if I go back to the attribute wrangle, oh, sorry, I just had the wrong node selected. Now if I go back to the attribute wrangle, I'll increase the size here, the max scale, to 2 or 3. And if I go to the top level, we can see that we have the scatter following this sphere. Now if we move this around, the scatter will follow. Nice. So that means that if we decide to change our mind later about the position, we will know that all our scatters and everything we set up based on this geometry will follow along. So that will do for now. And next we will look at controlling some more attributes, like controlling the direction, the p-scale fall off, and some clumping values.